Yes. Let's look at 9.4 now. So flipping your notes to 9.4, third page in. Okay, solving quadratic equations by using square roots. So until now, we've only been able to solve quadratic equations that are factorable. That's the only time we've been able to solve, is when we've been able to factor them. Okay, now we're going to learn another method to solve quadratics that sometimes aren't factorable. We're going to learn another way. Okay, it's going to open up our versatility, Jacob. So we can, so if we're going to go through this, x squared minus 9 equals 0. We're going to walk through solving that by factoring. Okay, so x squared is a perfect square, 9 is a perfect square, difference of two squares. So how would we factor this? Justin?
I mean, normally we just bring down the...
Yeah, we're going to do it the normal way we know.
Oh, okay. So x plus 3 and x minus 3.
Very good. We take the square root of the 1 plus square root of the other, and then the square root of the 1 plus or minus square root of the other. We do 1 plus 1 minus. Does it matter which one we put first or second? No, it doesn't. Okay? So then from here, what would we do? Nope. You make two equations. Help me with those equations, Grace. Mm-hmm. Yep, we make these equations. And we solve. So Sam, what would the x be in this first equation? Negative 3, right? We subtract 3 from both sides. 0 minus 3 is negative 3. And Sam, what would the equation x be in the second equation? Positive 3. Very good. So we end up getting negative and positive 3. Another way we can write that, by the way, is this. Have you guys ever seen that symbol? It's like a plus sign that's over a minus sign.
No.
Okay, so that would be a new symbol for us. Just kind of want to introduce it real quick. This symbol is plus sign over the minus sign. That just means a positive and a negative version. So we're just saying, this is saying x equal to a positive and a negative 3. It's both.
So it's like instead of writing both, it's just like...
Yep, so instead of writing a negative 3 and a positive 3, you can just write positive or negative 3. They're the same thing. These two are the same thing as each other. We always just put the plus sign on top. That's how it's written. It's just always a positive or negative 3. So that's how we solved it before, right? That's not new to us. That's old math. Plus positive or negative is new to us. But this part is not new to us. So if we're going to solve by taking the square root, we're going to walk through these 3 steps. What's the first step say? Isolate the squared term. What's isolate mean? Get it by itself. Okay? Get it by itself. Wherever it's at, we want it to be by itself. Keep it away. Okay? So what here is being squared right now? X. X has the exponent of 2 on it. It's being squared. So we want to get that term by itself. So how do we get that term by itself? Okay, we can move that to the other side, or we can also add 9 to get the other thing away from it. So if we add 9 to both sides, we end up getting x squared is equal to 9, correct? Okay? So now we successfully isolated the squared term. We found the squared term, x squared equals 9. Or excuse me, we found the squared term, x squared, and we isolated it. Make sure we're following along here on the right side. Make sure we're following along this, okay? Then it says to do what? Take the square root of both sides. We're going to take x squared, we're going to take the square root of that. We're going to take 9, we're going to take the square root of that. Now, what is the square root of x squared? What times what is x squared? X. What times what is 9? 3. So 3 times 3 is 9. What about negative 3 times negative 3? So are there 2 answers? So it's positive or negative 3. Because that would work as well. What? Okay. So we took the square root of both sides. What was your question, Grady? What do you mean? I put positive or negative there. Going, I'm like, what's your question? But it's the same thing, just in green. We get x is equal to positive or negative 3 because when we take the square root of both sides, we have to account for the positive and negative versions. Okay, when we actually take the square root of both sides, we have to account for the positive and negative versions. Because negative 3 can make this equation just as true as we saw over there. And then the last thing it says is what? What's our third step? Is it already by itself right now?
Yeah.
Yeah. Sometimes it won't be, and so sometimes we have to do this step, sometimes we don't. Okay, we'll talk about those. Questions on this process right now? We're gonna walk through it a lot more today. Yeah.
No, really?
No way, right?
It's not like we're talking about it.
Okay. So radical, we have some terms we want to talk about. Radical. So radical is the symbol that we use for the square root. It's the symbol that we use for the square root. And so it's drawn like this. Now, oftentimes you'll see it either like this, or it's a sharp slash diagonal line, straight up, over. And then I like to do this at the end, as you might have noticed, the little, like, almost like a hook thing at the end. You don't have to do that. That part's optional. I like it because it tells me that after this, it's the ending of it. Yeah, everything inside the radical comes before this little hook. So I like doing it because of that. I think it makes it look cleaner and easier to read, but you don't have to do that. So radical is the symbol. So this symbol that we put over the x squared and over the 9 here, we call it the radical. It's called the radical. Okay? Radicand, it looks kind of similar to that word radical, right? So it's probably related to it. Okay? So this is going to be what is under the symbol. So this is what is under the symbol or under the radical. So when we had the square root of 9 on this side, which one was the radicand? 9. 9 here is our radicand. I suggest writing that in there as well, just like I did. That square root of that 9 would be the radicand, whereas this, the actual symbol, would be the radical. I suggest writing that in and saying, oh, the number itself, or the x squared, or the 9, the variable, whatever it is, that's our radicand. The symbol itself is our radical. I'll let you have it for a second. Okay. So right below this, it says kind of what I just talked about. When we take the square root of both sides of the equation, we get a positive and negative answer. We get a positive and negative answer. So we often write this as, well, just if we have x squared is equal to 16, we get square root both sides, and we get x is equal to what? 4. But not only the positive 4, we also have negative 4. Because here's the thing. If we were to go through this, you don't have, I want you to write down what's in purple right now, but you don't have to write down what I'm going to do in this light blue right now. So I want you to write down what's in purple. You do not have to write down what I'm about to do in the light blue. The reason it's positive or negative 4 is if we have this original equation, x squared is equal to 16, if we were to plug positive 4 in for x, it would work. Because 4 squared is, in fact, 16. So that checks out. If we plug in negative 4 for x, what is negative 4 times negative 4? 16. So does this one work as well? So both of them are solutions. And we know that we should have how many solutions when we have x squared? 2, because of that exponent there. So that's why we have the positive and negative there. Is because both of these squared, positive or negative, would get that. Because when you square it, you basically just get rid of the negative. Questions on that? Alright. So on number 1, we're going to start walking through these. So our first step is to isolate the squared term, get it by itself. Is that done for us?
Yes.
Nice. Okay. So we're done with step 1. What would step 2 say? Eric, can you go ahead and read step 2 for me? Take the square root of both sides. We're going to draw a radical above both of these. We're going to take a square root of both sides. Just like whenever you add or subtract, you do it to both sides of the equation, right, Jacob? Yeah. Okay. So we're gonna do the same thing with square rooting. We're gonna do it to both sides of this equation here. So then we say, okay, what is the square root of x squared? What times what is x squared? X. And what times what is 4? 2. But not only just positive 2, positive and negative 2. And then is x already by itself? Yep, so we're done with step 3. So that one we really only had the one step. Because step 1 was done, step 3 was done. What if it's not a perfect square? We'll talk about that in a little bit. Ben already knew.
Of course, it has to get harder.
Every time, man. It gets me off guard every time.
Yeah, you start off with the super easy stuff, and then it actually gets to the stuff where you have to actually think.
Yeah, sorry for challenging you. Oh, okay. Yeah, weird question. Okay. So on number 2, we follow the same process. What's our first step? Isolate the square term, and we do that by adding 36 to both sides. So x squared is equal to what number? 36. Now that the square term is isolated, we move on to our second step. Hannah, what was our second step? Take the square root of both sides. Yeah, whatever was being squared, in this case x, by itself, take the square root of x of both sides. Ben, what is the square root of x squared? X. What is the square root of 36? 6, but not just the positive 6, positive and negative 6.
Isn't that every time?
Yes.
Always ready.
Yes. Whenever we take the square root of both sides of an equation, we have to factor positive and negative. Okay? Good question. Now our third step says what, Josh? Get x by itself. Is it though?
Yeah.
Oh, nice. Not to do that step yet. Okay. Questions on 2. Let's look at number 3. Okay? Number 3. First step is what, Justin?
Add 2.
Okay, isolate the square term. We'll start by adding 2. 2x squared is equal to 2. Is the square term isolated yet, Kale? No, because what's being squared? 2 is not being squared, but what is being squared? X, and that's not by itself yet. So how do we get this x squared by itself? Divide by 2 now. And now we have x squared is equal to what? X squared is equal to 1. Notice I just kind of said, here, I'm going to go up here because I ran out of room. And now that it's isolated, we do the thingy. What's the thingy?
Square root.
We take the square root of both sides. Okay? What is the square root of x squared, Graydon? X. What is the square root of 1, Graydon? 1. Positive and negative 1. Christian, what's our third step? Get x by itself. Is it already by itself? Oh, dang. We have our 2 answers. Positive and negative 1. I want you guys to try number 4 by yourself. Once you're done, or if you have questions, please raise that hand of yours.
Oh no.
Oh, yeah. Believe me. Yes. I'll check. Oh, no problem. You said no, so you're not. No, you're not keel check, you're Christian. Nice to meet you.
It's true, that's very true.
Okay, let's look at number 4. So our first step is to isolate the square term. How do we go about isolating the square term in this one? Add 6. Now that x squared, the square term is isolated, what are we going to do? Square root both sides. Undo the square. Squaring and square root. Squares and square roots undo each other. Just like addition and subtraction undo each other. They're inverse operations. So square and square root undo each other. So we're left with what on the left side? X. The square root of x is x squared is x. And then?
Oh, I was 5. I was gonna say, can I go to the bathroom?
Wait, when one of those rows goes back. Okay. What kind of 5?
Positive, negative.
Okay. Hey, so now our third step would be to get x by itself, but is it already by itself?
Yeah.
Nice. Questions on number 4. Okay, there's a little bit of a twist on 5. So what's our first step say? What's our first step say? Isolate the squared term. Here, what is being squared on number 5?
Oh,
X plus 3. The whole thing, x plus 3 is being squared. So on like 1, 2, 3, and 4, x squared is being squared. Here, x plus 3 is all being squared because where the square is and where the parenthesis is. Now, is this whole square term, is this by itself?
Yes.
Is there anything else with it on this side? No, so it is already isolated. Okay, it's already isolated. The square term is already by itself. Looks a little bit different, but it's already by itself. So now we go to our second step, which is to do take the square root of both sides. Now I just mentioned this thing how a square and a square root do what? Undo each other. They are inverse operations. I do not like the word cancel in math. They undo each other. They're inverse operations. So if we're square rooting the square, what am I going to write on this left side? X plus 3. Write whatever the radicand is without the square. And then what would we get on the right side? Not just 4. Thank you. Positive and negative 4. No.
That'd be kind of weird.
And if you tell me 4, it means it's just 4. If you tell me positive, negative 4, it means positive, negative 4. Oh, man. Okay. 3. You're going to say 4 anyway, though. So it's an extra 3 words. Thank you. Okay. So now, now our last step comes into play. Because what's our last step say? Good, x by itself. Is it currently by itself? No, but we can get it. Did you see your light flash before your eyes there?
No.
Okay. So how do we get x by itself right now? Subtract 3 from both sides. Now here's the tricky part. Is because do we know whether we're subtracting 3 from a positive 4 or a negative 4? No, because right now it's both. So here's what I'm going to do. Everybody pay close attention. Thank you. I'm going to write this negative 3 first. I'm going to write whatever is with it first. Then I will write the positive and negative symbol afterwards with 4. So we're at negative 3 plus or minus 4. Now what we're going to do is we're actually going to get both of our answers because we're going to split this, so to speak. So we're going to take this positive one, we're going to take a negative one, and we're going to say, we're going to have 2 possibilities for our 2 answers. We'll have one where we rewrite everything, and we make the 4 positive. We take the positive symbol. Then the the other one, what are we going to do with that 4? Instead of making it positive, we're going to make it negative. So I take this symbol, so to speak, and I split it up. I take this symbol and I split it up into one where it's positive, one where it's negative. Did anything else change in these two equations besides that one sign? No, everything else was the same. Okay? I did not change the symbol on the 3. I did not change the numbers. I just changed this positive and negative symbol. I made one positive, one's negative. Now we have two equations again. So what is this equation? What's negative 3 plus 4? And this equation, what's negative 3 minus 4? Negative 7. And these are the two answers. Jacob, I have to ask you one more time to stop that. You'll be saying after school. Exactly. Thank you. Alright. We've had two answers the whole time.
What?
They've just been positive and negative 5. Because is positive 5 the same thing as negative 5? No. So it's really been two answers the whole time. We just wrote it positive and negative. It's two answers though the whole time. All of these have had two answers. Okay. So I know it's kind of a new one. Let's look at number 6 because we'll have something similar here. So on number 6, 2x squared plus 1, or 2x plus 1, excuse me, all being squared is equal to 16. What's our first step? Nope. What's our first step always? Isolate the square term. Now what is the square term? 2x plus 1, because where is the square at? Outside this parentheses. So everything inside of this parentheses is being squared. So that whole thing here, this 2x plus 1 is the square term. So is it already isolated? Yes, it is, because is there anything else with this on the side of the equal sign? But this whole thing, this is our square term, because look at where the square is. It's out here.
But I thought x had to be by itself.
The squared term has to be by itself. Whatever is being squared is by itself. Here it was x, here it was x, here it was x plus 3. Here it is 2x plus 1. You don't need x by itself until the end. We just need the squared term by itself, which sometimes is x, but sometimes it is not. Good question. So the squared term is already isolated. So what are we able to do? Now we square root both sides. So we move on to our second step. And what happens with the square and the square root? They undo each other. Thank you for using that word. They undo each other. I do not like the word cancel. They undo each other. And what are we left with then? 2x plus 1. Left with everything else that's underneath the square root. Everything else that was in the radicand.
Wait, what is it? So confused.
Okay, about which part, Grace?
Like how the like what? 2x squared, like you can't square root that. Like you can't put that in half because x can't go to both sides.
We're not putting it in half, we're square rooting. So it's 3 half of 9. No, but 3 is the square root of 9.
But like x times x is x squared, but the square isn't with x yet.
Correct. But the square is on here. And so 2x plus 1 times 2x plus 1 is 2x plus 1 squared.
But then why didn't we write the square?
We didn't write the square here either.
I know.
Or here after we square root. 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 After we square root, that undoes the square. Which is why we never wrote it after any of those.
Well, if it undoes, then why? Oh.
That's why we're doing the square root, is to undo the
No,
square.
I know that, but like if 2x plus 1 undoes itself, then why are we writing 2x plus 1?
The square root undoes the square. And we're left with this. 2x plus 1 is not undone. The square is undone. Maybe this has one. Oh, yeah. Yes, you're saying something. What is the square root of 16? Positive or negative 4? Okay? Positive or negative 4. So now, we move on to our third step, which is what? Yeah. What's our third step? Get x by itself. What would be our first step to get x by itself? Subtract 1. You have a hand up, please. Okay? Where am I going to put this negative 1? In front of that, and then positive negative 4 afterwards. Is x by itself yet? No. Hand up, please. Okay, it's not by itself. How do we get x by itself still? Divide by 2. Very good. We divide this whole side by 2. And now x equal to negative 1 plus or minus 4 all over 2, correct? Okay. So now we say, what are we going to do with this plus or negative so we can actually get our two answers?
Okay, hold up, Mr. Russell. So you subtracted 1 to the other side?
Yep.
Okay, yes, you did.
So now we're going to split our equation into two, into one where this is a plus sign and one where this is a minus sign. So for the first one, we'll go ahead and make it plus. So x is equal to, everything else is the same, negative 1 plus 4 over 2. And the other equation will be what? Can somebody tell me? Graydon?
X equals -1 minus 4.
Very good. And I love that emphasis on minus 4 because that's what changed. Everything else was the same in these two equations because we split up this plus or minus. Okay, so now we solve this one on the left. Negative 1 plus 4 is 3 over 2. Are you okay with leaving that as an improper fraction? You betcha. Okay. Negative 1 minus 4 is negative 5 over 2. Are we okay with that being an improper fraction? You betcha. And we have our two answers, just like we had done with every other one. Questions on that? Okay. Ms. Haswell, would you be willing to pass out the scientific calculator?
Yes, absolutely.
So we're going to talk about right below this an exact answer versus an approximate answer. Exact means it is that. Approximate means what?
It's an
It's
estimation.
about that. Okay, it's close. So an exact answer is not rounded. You never round an exact answer. If it was exact, that means it was not rounded. And it's exactly that. It's not close to that, because if you round, that means it was close to that. It contains the radical. It contains that square root symbol, unless the radicand, the number underneath, is a perfect square. And Grace was kind of asking about that earlier. You're like, what if it's not a perfect square? And so far, we've had perfect squares at 25, 16, 9. Okay, so this is talking about what if it's not. Okay. An approximate answer is rounded. An approximate answer will be rounded, like to the nearest tenth or the nearest hundredth. And it'll be written as a decimal, because it was rounded. So, an exact answer we will not write as a decimal, but an approximate answer we will. Here's an example. The square root of 12. I'm going to write the square root of 12. This is exact. But if we take these calculators, did we run out?
No, what do you mean that? What is that? After
It means it was not rounded. And that's a but afterwards. But, the second half of the sentence. Okay? But, if you take this calculator here, that you guys have, take your calculator, and what you should do on most of these, a few of them are different. Williams, can you hold your calculator so I can see your hand, buddy? Alright, so Williams and Crazy are really different. Devin, are you going to do this activity with us? Please take your calculator. So, take your calculator, those who have those blue calculators in the back, most of us, okay, except for Devin and William, I'll show you guys in a second. You would take, there's a button here. If you turn the calculator on, first of all, there's a button that's light blue at the top left. What's that say? Second. Push that button, and at the bottom left of your screen, you see that the word second popped up. Then if you go down, if you look at the button that says x squared on the far left side, right next to the number 7, what do you see in light blue above that? The square root symbol, right? Our radical. So push that x squared button after you push second, and what pops up on your calculator screen? The square root symbol with the parenthesis, right? Does everyone have that symbol on there? Okay. So once again, so push second. Perfect. Okay. And then you would type in 12. Then you'll type in 12. And there's a parenthesis right above the 9, so you'll push that to close it. Now push enter. Now push enter. After you type in square root of 12, push enter. Sorry that you're taking it. Okay. So let's round to 2 decimal places, the hundredth spot. What do you get?
3.46.
3.46. So square root of 12 is exact, but 3.46 is approximate. I'm gonna give you guys calculators. Did you get it? Okay. I'm gonna have you borrow this. Okay. Oh, you got it on there. Okay, perfect. Okay. Okay. So. Yep. Okay. And so when we got pushed to the square root of 12, did we get an exact answer? Was it like 5? Was it 6? Was it 3? No, it was this long decimal, right? And we cut it off early. So that is approximately 3.46. It is not exactly 3.46. It's close to that. However, it is exactly the square root of 12 because this wasn't rounded. So what we're saying is the exact answer contains the radical. It still has a symbol unless it's a perfect square. Because is 12 a perfect square? Is anything times 12, or is anything times itself 12? No. So because 12 is not a perfect square, this would be the exact answer. 3.46 is the approximate answer. Questions on that? Okay, so we're going to have to round to as many decimal places as specified. It will either say, or I will tell you, or you can ask how many places to round to. Here I told you to round to 2 decimal places, which would be our 100th spot, because it takes 100 of these to make a whole. Let's look at number 1. We're going to solve the equation. We're going to give exact and approximate answers this time. Rounding to how many decimal places? 2. Okay, rounding to 2 decimal places. So on number 1, x squared is equal to 8. What's our first step when solving the square roots? Get the squared term by itself. Not necessarily x, we don't want to say x because that's going to confuse us. Get the squared term by itself. What is being squared, Krista, in number 1? What is being squared? X. And is that already by itself? Yeah. Awesome. So we move to our next step. Jacob, what's our next step? Step 2, what's our next step? Look at your sheet. Top right. Put it on there, buddy. Nope. You already passed it. You already passed it. Yep, top left. Top right. What's step 2 say? So 1, 2, 3.
Take the square root of both sides.
Take the square root of both sides. We still do this on paper. We are not picking up the calculators yet. We're not there yet. We take the square root of both sides once that square term is by itself. And what is the square root of x? X. Is 8 a perfect square? No. So we write x is equal to positive or negative square root of 8. It's not a perfect square. So we're going to write that at first. Now, this would be our exact answer. This would be our exact answer. We didn't round even a little bit. So this is our exact answer. However, we're asked to find the exact and what other answer? Approximate. So, we would find our approximate answer by typing into our calculator square root of 8. So you type in your calculator square root of 8. And so x would be approximately, and notice the symbol I'm going to draw here for approximate, guys. 2 squiggly lines, because it's like equals a straight line, because it's exactly that. Squiggly lines means it's kind of it. It's not super sure. It's kind of wavering through. Okay, when you're not super sure, you say you're wavering. Okay, so lines are kind of wavering through because they're not exactly that. And it's exactly positive or negative. Somebody tell me. 2.83.
Do you want us to round?
I want you to round to 2 decimal places. Yep.
So if it's like 8,
Round to 2 decimal places. Yep. We're good. We're good. We're good. Now this. What? No, what did you say? Okay, but we rounded 2 decimal places, so this 8 tells us to round up or down. Yep. Thanks for asking. Okay, and now this would be which answer? This is the approximate answer, which I'm okay with us shortening down to approx like that. So this would be the exact answer. This is our approximate answer. So you really don't have to do 2 separate problems. The exact answer just stops a little sooner. The approximate answer just goes one more step further right now.
wait, why did you write the approximate or the square root sign for 2.83?
Because we already did the operation of square rooting. Okay, so just like after you, that's a great question. So just like after you add 2 things together, if you do 3 plus 3, what do you get? 6. Do we write this plus symbol anymore? No, because we already did the operation. If we do 3 times 3, what do you get? 9. Do we still put a time symbol though? No, you look at us like we're silly if we did that. Because you already did the operation. So after you do the square root, after you take the square root of 8, and you get 2.83 approximately, you don't have to write the square root symbol anymore. Because you already did that operation. So just like with addition, multiplication, subtraction, division, any of those, once you do the operation, you don't write that symbol anymore. You don't need to. Does that answer your question, Grace? Thank you for asking. I needed to bring that up anyway, so that works out very well. Okay, we're going to look at number 2 here. What would be our first step in solving this? Get the squared term by itself. What is being squared here, though? It is x, okay? So we're going to get the squared term by itself. How do we get the squared term by itself, William? Add 2 to each side. X squared is equal to 15. So now we got the squared term by itself. Not necessarily x, but it is this time. What do we do? Square root both sides. And we say, what is the square root of x squared? X. Do we know the square root of 15 off the top of our head? Is it a perfect square? No. So for our exact answer, what am I going to write? X equals what kind of square root of 15? Positive or negative, because we have to have 2 answers. So we have the positive answer, we have the negative answer. This would be our exact answer. But we don't stop. Why don't we stop? So we have to find the approximate. So type it into your calculator, round the 2 decimal places, and raise your hand. Do not put raise your hand to tell me what this would be. Okay? Tail. 3.87 would be our approximate answer. Now, do you have to label this exact and approximate every time? Because am I going to know which one's exact and which one's approximate? Yeah. Because the exact has a square root, the approximate has the squigglies, and it's a decimal.
Can you just write E and A to the second thing too?
You don't have to even write anything, but if you want to write E and A, you can. It's not broken. Oh, okay, maybe it is. Okay. So if we were to have this answer, just kind of spitball here, guys. If we were to have this x squared is equal to 16, just like we did earlier, and we square root, we get x to equal what? Positive or negative 4. Now, is there an approximate answer for this? No, because is there anything to round? No, so there's only one answer here, and it would just be, there's only one type of answer. It's only the exact. There's no approximate when you don't have to round. So that's all something that can confuse us, is if we get a perfect square, we don't have to find an approximate answer.
Oh,
When we
it's
find-
only approximate if there's stuff after the decimal.
Yes. Yep. It's only approximate. There's still stuff after the decimal that we have to round.
Wait, but that is like
It's just the exact answer. Did we round even a little bit? No. Is there a need to round? No. So there's no approximate answer. Here was a need to round, so we had to. Here, no need to round, so we don't have to. All right. Now, we're going to do number 5, and then we're going to be done with these notes. Yep. Yes. Okay. So, our first step is to do what? Get the squared term by itself. What is being squared here? 2x plus 3. Is it already by itself? Awesome. So now what do we do in our second step? Square root both sides. The whole sides of the equation. Now what's the square root and the square do? Undo each other, and we're left with 2x plus 3. Now on the right side we have positive and negative what? Square root of 7. So we haven't taken the square root yet. We don't, and 7's not a perfect square. Okay? Now, here's where it gets a little bit different. We're going to look at this. Because now, we still have to do our third step before we start moving into exact and approximate stuff. We still have to do our third step. But what's our third step? Get x by itself. So how do we get x by itself? Minus 3. And where am I going to put this minus 3 at? In front of the 7. I know it kind of looks weird, but we want that positive or negative before everything. And we like to put our radical at the end.
Wait, why didn't you?
Let me.
Okay, wait, why did you put it in front?
It's much easier for us to have it in front because then we don't have to worry about changing this sign. Whereas if we put this in front, then we write it. When we end up splitting the sign up, we might end up thinking, oh, we have to change this sign, but we don't. And so we write it like this because then we don't even bother with that confusion. There's no chance of it confusing us there, whereas over here, there would be. How else would we get x by itself? The whole side, correct? Okay. So x is exactly negative 3 plus or minus square root of 7 over 2. Is there any more that we can truly do with this unless we were to put this in a calculator and round? No. Because we can't combine negative 3 and the square root of 7 because we don't know what the square root of 7 equals. And we can't divide the square root by 2. And we don't want to split up the fraction. So this would be our exact answer. There's nothing more you can do there for the exact answer. But for our approximate answer, what I'm going to ask you to do is I'm going to ask you to type in the square root of 7. And we're just going to replace just this part in our equation here. So so type in the square root of 7. And what do we get approximately? 2.65.
Love that.
Okay. Yeah, it's supposed to be a squiggly. So x is approximately negative 3 plus or minus 2.65 over 2. But now, can we add and subtract negative 3 and a 2.65? Yes, so we will. So now we'll separate these equations into two other equations. Where x is approximately negative 3 plus 2.65 over 2. And I want somebody to raise your hand for the second equation here. Okay, Chris, I'm actually going to have you help me out with that one. You didn't raise your hand. Very good. Okay, now we've already started using calculators at this point, so you can continue using calculators in this problem if you so choose. What is negative 3 plus 2.65? Ben? Nope.
Oh,
Negative what? 0.35 over 2. Let's go ahead and finish solving this equation. Because if you have negative 3 plus 2.65, difference of 3.35, but it's negative. In your calculator, go ahead and do negative 0.35 divided by 2. You're on the 2 decimal places.
Yeah, where's the negative?
What do you mean? You don't have to write it in the negative, actually. You can just do 0.35 divided by 2, and we know we're going to make a negative, right?
Just the subtraction sign.
Negative 1.75, which rounds up to negative 1.8, or 0.18, excuse me. That's one of our approximate answers.
Wait, we divided by.
You get 0.175, and it rounds up, since we're doing 2 decimal places. Now, for this other one, negative 3 minus 2.65 is what then? Negative 5.65. And we divide that by 2 to get x to be approximately what rounded to 2 decimal places, guys? 2.83. Now we have negative 2.83. So those would be our approximate answers. Okay, so what would you do? What would you do if this was a little too much information too quickly and you need some extra help?
Watch the video.
Watch the video. Go back and re-watch the part where it didn't make sense to you anymore. So if you're like, Mr. Kossel, you lost me back right here, but we didn't have time to finish it out. Or we didn't have time to do enough examples for me. Well, you can watch the video and re-watch some of these and re-watch the exact part where you got lost, and you can help find yourself again. No, I need those calculators back. You can do them on your phone, though. You can do a experiment on your phone. And when is this going to be due, guys? Next class, which is not for a while. It's not for a week from today. So,